Assalamualaikum warahmatullahi wabarakatuh. Hi student, hi science student, and hello everyone. Welcome to IPST channel. So let's introduce myself first. My name is Anissa Priska from IPST 2018, and today I have an interesting topic. What is that? Are you curious? So let's jump to the next slide.
Yes, today's topic is about force. Maybe some of you don't know about force, or maybe some of you already know but are still confused. Okay, here is the time we can discuss one by one about the concept of force. And here is our table of content today. So there are 5 points that we discussed today. First is definition of force, the effect of force, type of force, resultant force, and the last is Newton's law. First thing is about the definition of force. Have you ever heard what is force? Yes, force is a pull or push acting upon an object as a result of its interaction with another object. So let's see the picture. In the picture, you can see a child pushing the box, and the box will move. Means that the child is giving force to the box, and there is also a child who is pulling the box, which means that the child is also giving the force to the box, so the box will move. From here, we know that the force that will be applied to the object will affect the object too. But the concept of force is not just a push or pull the object. Let's look at this square. The square is stationary. The question is there any force work here? Yes or no? The answer is yes. Why? Because when the box is placed on a surface, there is a normal force that acting on the box. There is also a force of gravity, gravitation force. Because the gravitation and the normal force is equal, so the two forces are balanced, with the net force equal to 0. Therefore, even objects that are at rest actually have a force, but because net force is equal to 0, no change in velocity is generated. An object will result in a change in velocity if its net force is not equal to 0. Next is the effect of force. Force not only affects the change in speed, but there are several other things that arise as a result of the force effect. First is change the position of object. For example, when we put the erase in position A and then we push or pull the erase until the erase moves to the position of B, so the position is changed, right? So therefore, force affects position. Second, change the direction of object. For example, when we hitting a baseball ball that initially points straight, after being given a force by being hit, the ball changed to a turn. The third, change the speed of object. Of course, for example, at first an object at rest with v equal to 0 or speed equal to 0 after being given a force will change the value of speed acting on the object. And the last, change the shape of object. For example, when we play Play-Doh, which at the first day Play-Doh is round, but after given a force by our hands, the shape can change to flat or other shape and vice versa. The symbol of force is F, and the unit of force is Newton per kilogram meter per second square. The unit derived from the adopted name of the discoverer. Is it Sir Isaac Newton? Force is also included in the factor quantity, mean a quantity that has magnitude and direction. The tool used to measure the force is a dynamometer. And here is the picture of the dynamometer. Next, there are two types of force. First is contact force and the second is non-contact force. Contact force is the force that acts on the body either directly or through a medium, so like we touching directly the object. And non-contact force is the force that acts through space without making direct contact with the body. So to make it clear, we jump to the example of contact and non-contact force. For contact force, the example is muscular force, mechanical force, the friction force. And for non-contact force, the example is gravitation force, magnetic force, and electrostatic force, and also many example others of the contact and non-contact force. Resultant of force. The resultant force is described as the total amount of force acting on the object or body along with direction of the body. The resultant force formula is given by resultant force equal to force 1 plus force 2, where the force 1 and force 2 have same direction on the object, while the resultant force equal to F3 or force 3 minus force 4, where the F3 and F4 have a different direction on the object. So let's the example below. There is a box. We apply a force of 14 Newton to the left. Then we give it another 20 Newton of force to the left too. Then calculate the resultant force acting on the box. The answer, because the two forces have the same direction, so we just need to add the two forces. So the answer is 14 plus 20 equal to 16 Newton. In finding this force resultant, what needs to be considered is the direction of the force that given to the object. So the point is the direction of the force. The last topic is Newton's law. There are three of Newton's law. First, Newton's first law states that an object will remain stationary or move at a constant speed unless an external force acts on it. The formula is sigma F equal to 0. For example, if we have the table and the table in the stationary position, so the table will still in stationary position, or they can move until there are force that acts on the table. Or like this picture, the example is when we drive a car and we stop suddenly, so we and the passenger in the car will move forward. So is that the phenomena in Newton's first law? And the second Newton's second law states that when an object is subjected to an external force, it will move at the same acceleration. The greater the force, the greater the acceleration. The formula is sigma F equal to m times a, where the F is force, m is mass, and the a is acceleration. For example, in this picture, we see that the people pull the object with one mass. We assume that it is one mass, and there are also the people that pulling the object with four mass. So in the first picture, we need the force. But in the second picture, we need the more force. So the greater of mass, the greater we need the force. So is it the phenomena in Newton's second law? And next, Newton's third law states when two bodies interact, the force on the bodies from each other are always equal in magnitude and opposite in direction. The formula is F action equal to minus F reaction. And the example of this phenomena is in the rocket. So we can see the action is mass ejected backward at high speed, and direction is the rocket move forward. And that's all for our topic or our material today. I'm sorry for any mistake, and thank you for your attention, and see you bye bye in the next video.